Beginning on page 42 in chapter 4, we're looking at subnetting. Subnetting means that once we have determined that, for instance, a Class B network with the possibility of 16,000 some odd network IDs, 16,000 some odd host IDs, does not meet our company's growing needs anymore, we can start robbing bits from the free octets of the default subnet mask. The overview for chapter 4, we're going to define what is a subnet, how to implement subnetting, what are subnet mask bits, defining a subnet mask, defining subnet IDs, defining host IDs for a subnet. The first topic, what is a subnet? As we see in the example slide, a subnet is a physical segment of our corporate's infrastructure. For instance, we see the main network backbone, we have a network ID of 131.107.12.0. Notice we have two physical segments also. We have subnet 1 and subnet 2. Notice the difference in the IP addresses. The subnet ID in the third octet differs for each of our three domains, or our three subnets. These are physical groupings of computers such as engineering, sales, and possibly marketing. To implement subnetting, our first step is to determine the number of required network IDs. How many new networks do we need to create inside of the organization? We need a network ID for each new subnet, whether this be engineering, sales, whether it's a marketing type strategy, or possibly a geographical strategy. Maybe we need to create a new subnet for Dallas, California, Florida, whatever it may be. We also need a subnet ID for each wide area connection. Remember, the WAN port on the router is the far side of the router. That's the one directly connected to the internet. We also need to determine the number of required host IDs per subnet. We need an IP address or a host ID for each host on the physical segment. The host is defined as, once again, either a computer interface, printer interface, router, anything that needs to obtain an IP address. We also need to define one network ID, we also need to define one subnet mask based upon the requirements that we have discovered, how many network IDs and host IDs are needed. We then need to define a unique subnet ID for each physical segment based on the subnet mask that we have created. We also need to define a valid number of host IDs for each subnet based upon our newly created subnet ID. Next up, we're looking at what are subnet mask bits. As we see, for instance, this is an example of a Class B address. The first two octets, remember, are used for the network ID. With a Class B IP address, the subnet mask is always going to be 255 in the first two octets, leaving two free octets to create subnet and host IDs. The number of hosts, notice, if I start moving bits or borrowing bits out of the third octet, the subnet ID, to create new subnets, all of a sudden start losing bits for the host IDs. So we have a trade-off. At this point, notice between the two free octets we have available, we have a possibility of 65,534 maximum down to 254 in the last octet. So we do have to take into consideration the trade-off between the two. To define a subnet mask, the first step is to convert the number of segments that we need to create to binary. We then count the number of required bits used to create this amount of subnets. In our example, once again, we're using a Class B address. We've determined that we need to create 6 new subnets. Possibly our organization has been merged with another corporation. We then convert this decimal value to a binary value. Notice that the decimal value of 6 represented in binary is 110. Our third step is to count the number of bits used to represent the decimal value into binary, which in our case is 3 bits. Notice that we're counting the 0 also. We see 1, 2, 3 bits. The next step is to count the number of bits to represent the decimal value into binary. We then take our 3 bits that we've represented, flip them, turning all bits on. These become the high order bits in the first free octet. Notice that once we count up the first 3 high order bits that we've used, we come up with the decimal value of 224, which is the 4th step. So our newly created subnet mask for the Class B address to support 6 additional subnets is 255.255 in the first 2 octets, 224 in the 3rd octet. The next step, we need to define subnet IDs. Remember that we have created, for instance, off a Class B IP address of 131.107.7.0, the default subnet mask of 255.255.0.0. We have created a new subnet ID. We have created a new subnet mask of 255.255.240.0. The next step is to determine the number of subnet IDs that we need to create, or the valid range of subnet IDs that we need to create. The first step in the process of defining subnet IDs is to take the lowest high order bit that we've used to represent the custom subnet mask. In our case, the lowest high order bit would be a value of 32. We start the process by listing all zeros in binary format. Notice our 3 bits that we have used to represent the binary value of 224. We first of all list these 3 bits as 0, come up with the decimal value of 0. Our next step is to represent the decimal value of 32 into binary. We then increment this value by itself until we come up with all ones and the number of bits that we have used to represent the number of physical segments we need to create. In our case, we had created 6 new physical segments with the Class B subnet mask. Taking the lowest high order bit value of 32, starting out with all zeros, remember that we cannot use all zeros because that means this network only. In other words, we can only communicate with the local machine. We then increment this value until the 3 bits used to represent our initial decimal value become all ones. And we mark this value out also because remember, all ones determines that this is a broadcast address. So our valid range of subnet IDs based upon our requirements are 32, 64, 96, 128, 160, and 192. We also see a shortcut on the next slide to defining subnet IDs, which is, notice that the first step, we list the number of bits in high order used for the subnet mask. In our case, it looks like we've came up with the value of 192. The first step is to list the number of bits in high order used for the subnet mask. We have a decimal value of 192, which is represented as 11 and 6 zeros in binary format. Notice we've taken the lowest high order bit, represented this, and then we add this value to itself. We first of all convert the bit with the lowest value to decimal, and then increment the value for each bit combination. We start out with all zeros once again, which we cannot use because this means this network only. We then increment this value by itself until the next incrementation pushes us over 255. Notice 64 plus 64 is 128. 128 plus 64 is 192. We cannot use the 192 because the next incrementation pushes us over 255. So our valid ranges, once again, are 64 and 128 in this example. To define host IDs for a subnet mask, remember the host IDs are the individual machine or interface IDs, or IP addresses. Once again, we have already determined the appropriate number of subnet IDs as being 32, 64, 96, 128, and so on. Notice that each subnet ID indicates the beginning value in a range, and the ending value in that certain range is 1 less than the beginning value of the next subnet ID. Now it's confusing whenever we first see this because on the initial conversation, it looks like the only appropriate values for the first free octet are 32, 64, 96, and so on. But they are actually, if we add this value to itself, subtract 1, or end our addition at the beginning of the next range, such as 32 through 64. Notice 32 and 32 is 64, minus 1 is 63. With NC 64 plus 32 is 96, minus 1 is 95. So our valid ranges of subnet IDs are actually 32 through 63, 64 through 95, and so on. Now we're once again discussing the subnet ID, not the host ID at this time. We're looking at the third octet and the IP address. The valid host IDs for each range, such as 131.107.32.1 through 254, 32.1 through 254, all the way up to 63.254. So our actual ranges are not only what we see in the first column whenever we're determining the subnet IDs. They're actually from the value of 32.1 all the way down to 223.254. In review, in Chapter 4 we've looked at what is a subnet. A subnet is a physical segment on a network. This may be a physical segment determining a department type, such as engineering, sales, marketing, what have you. It could also be the physical levels on a floor or inside of a building. This could also be a geographical location, such as Dallas, Texas, Florida, New York, what have you. We've also discussed how to implement subnetting. Remember, the first step was to determine the number of network IDs that we need to create. We've discussed what are the subnet mask bits and their equivalent decimal formats, how to define a subnet mask, defining subnet IDs and also host IDs.